First, characteristics of normal distribution. So x-axis, y-axis, this is a normal curve. X is equal to mu or z is equal to 0 is the center line. First one, a normal distribution is symmetrical about x is equal to mu or z is equal to 0 and bell shaped. Normal curve has single peak point, right? Only one peak. The distribution is unimodal, right? Single peak. The mean of the normal distribution lies at the center of the normal curve, right? X is equal to mu, z is equal to 0. Due to symmetrical, the median and mode also lies at the center of the normal curve. Hence, the normal distribution mean equal to median equal to mode is equal to mu. The tail of the normal curve extended infinitely and never touch the horizontal axis, that is x-axis. It will not touch the x-axis. It will go very nearby, right? This is right tail, this is left tail. So the normal curve approaches asymptotically on both sides of its x-axis. X-axis is the asymptote of the normal curve. So there are two parameters for normal distribution, mean mu and standard deviation sigma, right? Which are completely determine the distribution. Both mu and sigma give the clear picture of the normal distribution. So no portion of the curve lies below the x-axis. So normal curve always above the x-axis. F of x or p of x being probability function can never be negative. The point of inflection, right, of the curve are x is equal to mu plus or minus sigma. Mu plus sigma, mu minus sigma, the both sides, right? That is the point. So inflection point, right? Next point, as x tends to infinite, f of x or p of x tends to 0, the maximum probability occurring at the point x is equal to mu and is given by maximum of f of x is equal to 1 by root 2. Since mean is equal to median is equal to mu, the ordinate at x is equal to mu or z is equal to 0 divides the whole area into two equal parts. Further, since total area under the normal probability curve is 1, so it is dividing the x is equal to mu or z is equal to 0, dividing into equal part. Left side part is 0.5, right side part is 0.5 area. The area of the right of the ordinate as well as the left of the ordinate at x is equal to mu or z is equal to 0 is 0.5. Also, by virtue of symmetry, the quartiles are equidistant from the mu. So mean quartile deviation, right? Q3 minus median, it is equal to median minus Q1. That implies Q1 plus Q3 is equal to 2 times median. So taking that Q1 to left hand side, median right side median to left side. So median plus median, 2 median, right? That is equal to 2 mu. Since the distribution is symmetrical, the moment coefficient of skewness is given by beta 1, that is equal to 0. This implies gamma 1 equal to 0 because gamma 1 depend on beta 1. The coefficient of kurtosis is given by B2, right? Since the distribution is symmetrical, all moments of odd order about the mean are 0. That is mu 2n plus 1 equal to 0, n is equal to 0, 1, 2, etc. And this mu 1, mu 2, mu 1, mu 3 odd order, right? Mu 5 all are 0. The moment about mean of even order are given by mu 2n is equal to 1 into 3 into 5, etc., etc., 2n minus 1 into sigma power 2n, n is equal to 1, 2, 3. So putting n is equal to 1 and 2, we will get mu 2 is equal to sigma square and mu 4 is equal to 1.3 sigma power 4. 1 into 3 sigma power 4, that is 1 into 3 means 3 sigma power 4. So beta 1, that is equal to mu 3 square by mu 2 cube, that is a formula, that is equal to 0. And beta 2 is equal to 3 kurtosis, right? So B2 is equal to formula mu 4 by mu 2 square, 3 sigma power 4 by sigma power 4, that is equal to 3. Mean deviation about mean or median or mode, right? Since mean, median, mode are equal, is given by md is equal to root of 2 divided by pi into sigma. So that value is 0.7977 9 sigma or 4 by 5 sigma. Additive property or reproductive property of normal distribution. A linear combination of independent normal variate is also a normal variate. So if x1, x2, xn are independent normal variate with means mu1, mu2, etc., mu_n, and standard deviation sigma 1, sigma 2, etc., sigma n respectively, then their linear combination a1 x1 plus a2 x2 plus etc., an xn, where a1, a2, an are constant, is also a normal variate with mean a1 mu1 plus a2 mu2 etc., an mu_n, and the variance a1 square sigma 1 square plus a2 square sigma 2 square plus etc., plus an square sigma n square. In particular, if we take a1, a2 all are equal to 1, then we will get x1 plus x2 etc., xn is a normal variate with mean mu1 plus mu2 plus etc., mu_n, and variance sigma 1 square plus sigma 2 square plus etc., sigma n square. Thus the sum of independent normal variate is also a normal variate. This is known as reproductive or additive property of normal distribution. If we take a1 equal to 1, a2 equal to minus 1, a3, a4 all are 0, then we will have x1 minus x2 is a normal variate with mean mu1 minus mu2 and variance sigma 1 square plus sigma 2 square. Hence the difference of independent normal variate is a normal variate. If we take a1, a2, etc., which is equal to 1 by n, then we have x1 plus x2 plus etc., 1 by n x1 plus x2 plus etc., xn is a normal variate with 1 by n sigma I is equal to 1 to n mu I. Mean variance is 1 by n square sigma I is equal to 1 to n sigma I square. If x1, x2, xn are identically independent and distributed normal variate, each with mean mu and variance sigma square, then xi is a normal variate with mean mu and variance sigma square. Then x bar, which is equal to 1 by n summation I is equal to 1 to n xi, that is a normal distribution with mean 1 by n summation I is equal to 1 to n mu, comma variance 1 by n square summation I is equal to 1 to n sigma square. That is a normal distribution. If you put mu n times, you will get n mu, right? Mu plus mu plus mu summation. So n mu by n, that is mu, and summation sigma n square, n times sigma square. So n sigma square by n square. So x bar is a normal variate with mean mu, variance sigma square by n. Hence the mean x bar of n identically and independent distributed normal variate, n is normal variate mu sigma square, is also normally distributed with the same mean, but variance is sigma square by n. Next property, quartile in terms of mu and sigma are given by q1 is equal to mu minus 0.6745 sigma and q3 is equal to mu plus 0.6745 sigma. Quartile deviation is given by qd quartile deviation, which is equal to q3 minus q1 by 2, that is equal to 0.6745 sigma, that is equal to 2 by 3 sigma. Quartile deviation is 2 by 3 sigma or 4 by 6 sigma. You can multiply 2 and 2, and so otherwise 5 by 6 into 4 by 5, that is 5 by 6 mean deviation, right? So qd is equal to 5 by 6 mean deviation. Next we have approximately qd is to quartile deviation, mean deviation ratio, standard deviation proportion 2 by 3 sigma is to 4 by 5 sigma is to sigma, 2 by 3 is to 4 by 5 is to 1. So qd is to md is to sd is equal to, is proportionate with 10 is to 12 is to 15. From 16 and 17 we also have 4 into standard deviation equal to 5 into mean deviation, which is equal to 6 times quartile deviation. Area property, the total area under the normal curve is equal to 1, that is unity, and the percentage of distribution area under the normal curve is as follows. The area between x is equal to mu minus sigma and x is equal to mu plus sigma is 68.27% of the total area. So probability of mu minus sigma less than x less than mu plus sigma, which is equal to 68.27, or otherwise divided by 100, 0.6827. So this is the one. So this area is 68.27 percentage. Next, the area between x is equal to mu minus 2 sigma and x is equal to mu plus 2 sigma, which is equal to 95.45%. So probability of mu minus 2 sigma less than x less than mu plus 2 sigma is equal to 95.45% and divided by 100. That means, right, 0.9545. That is probability of minus 2 less than z less than 2, which is equal to 0.9545. So this is the area. Right. Next, the area between x is equal to mu minus 3 sigma and x is equal to mu plus 3 sigma is 99.73% of the total area. That is probability of mu minus 3 sigma less than x less than mu plus 3 sigma is equal to 99.73. That is nothing but 0.9973. This is nothing but probability of minus 3 less than z less than 3, which is equal to 0.9973. So it is like this. Thanks.